I want to introduce our group member. First, we have Ashraf, Rafiq, Asif, and my name, Hariri. First, we go objective project. Firstly, to collect data on the outcomes head or tails through repeat coin toss for 30 times. Second, to calculate the experimental probability of the coin toss. Third, to find the theoretically probability of getting heads or tails when a fair coin is tossed. And lastly, to find and compare experimental and theoretical probabilities by tossing the coin multiple times.
So we are going to move to the next page, which is project significance. The purpose of this project is to help students understand and apply the concept of probability in everyday situation. Probability is a measure of how likely an event is to occur, expressed in fraction of percentage. The higher the probability, the more likely the event will happen. Common example of probability in daily life is toss a coin, spin a whisk, or selecting a random twist, such as select a chocolate for a box. For this project, we will focus specifically which the probability of obtaining heads or tails when tossing a coin. By engaging with this project, students will be able to understanding of probability, enhance their problem-solving skills, and recognize how this concept is integral to everyday situation. So next, we are going to go to methodology of experiment. So first step, we are going to use a coin that have this different surface. Next, we are going to toss or spin this coin to get any of the surface. After that, we are going to record the result of tossing coin, whether it tails or face head. And then we are going to repeat the process 1 until 3 for the 30 times straight. Next, we are going to record all the outcomes of the tossing coin in a frequency table. After that, we're gonna calculate the experimental probability of getting heads or tails by using a formula. We also gonna calculate the theoretical probability of tossing coin using a formula. And then lastly, we're gonna calculate the percentage of difference between the experimental probability of throwing heads and tails by using a formula.
Okay, we go to 3.0 finding and calculation. So for the A question, data collected in experiment 1. So the data outcomes in experiment 1 is head and tail. So the number of time that we get from head is 20 frequency and the tail is 10 frequency. Okay, the next question, B. Find the experimental probability of getting heads. So in this question, we need to use the formula. The formula for experimental probability is number of time an event occurs divided by total number of trials. So the number of time event occurs for the head is 20, and the number of trial for the head is 30. So we need to divide 20 divide by 30, and the total is 2/3. The next question, C. Find the experimental probability of getting tails. So we need to use the same formula as before. So the number of time event occurs for tails is 10, and the number of trial for the tail is 13. So we just need to divide 10 divided by 13, and the total is 1/3. Okay, for the next question, B. What is the theoretical probability of throwing heads? So in this question, we need to use the formula number of favorable outcomes divided by total size of sample space. So the number favorable outcomes for throwing head is 15, and total size of sample space for throwing head is 13. So 15 divided by 13, and we get 1/2. And the next question, E. What is the theoretical probability of throwing tails? So in this question, also use the same formula as before. So the number of favorable outcomes for throwing tails is 15, and total size of sample space for throwing tails is 13, and so 15 divided by 13, we get 1/2. Okay, for the next question, F. What is the difference between experimental probability of throwing heads and theoretical probability of throwing heads? Right answer is a percent rounded to the nearest whole percentage. So in this question, to find the difference between experimental probability of throwing heads and theoretical probability of throwing heads, we need to use the formula that is experimental probability minus theoretical probability of throwing heads. So experimental probability of throwing head is 2/3, and we need to minus theoretical probability of throwing head, that is 1/2. So 2/3 minus 1/2, and the total is 1/6, and times 100. So we get 16.6667. So for the next question, G. What is the difference between experimental probability of throwing tails and theoretical probability of throwing tails? Right, the answer is a percent rounded to the nearest whole percentage. So this question also use the same formula as before. Experimental probability of throwing tails minus theoretical probability of throwing tails. So experimental probability of throwing tail is 1/3, and theoretical probability of throwing tail is 1/2. So 1/3 minus 1/2, and we got negative 1/6. So negative 1/6 times 100, and we get negative 16.6667%.
Then we go to 4.0 extra question. The probability distribution of a discrete random variable s is given by fs if s equal to 1, 2, 3, 4, and 5, s equal to s for s over k. Then if s equal to 6, we use 1.4, 1/4. And if otherwise, we use 0. For question A, determine the value of k. So firstly, we create a table to find the value of probability of s. So after we get the probability, we add all the probability and equal it to 1. Then we get 15/k plus 1/4 equal to 1. And lastly, we get our answer k equal to 20. For question B, find probability s greater and equal to 4. For this question, we add the probability of 4 plus probability s equal to 5 and probability s equal to 6. Then we get our answer 7/10.
We move to question C. Given that the discrete random variable w, which is x plus 3, over 3, determine the value of variance for W minus 2. So what we need to do it is, we need to factorize them one by one. For example, variance for W minus 2. So we factorize them, variance for W plus variance minus 2. For we move forward in front, so we have 4 square variance W plus variance minus 2, as we know is variance over 2, we have 0, and then we got 16 variance W. Next, variance W question give us that x plus 3 over 3, so we just put them variance x plus 3 over 3. We use the same method like before. Variance x 3 plus variance 1, so we calculate them, and we have 1 over 9 variance x. After we finish doing that, we need to put them into the same question like this. Variance for W minus 2 equals to 16 variance W. Variance W, as we know, as 1 over 9 variance x. So we need to put them into this question like this. Variance for W minus 2 equals to 16 1 over 9 variance x. We calculate them, and we have 16 over 9 variance x. And then we need to find variance x. Variance x, as we know the formula, which is EX square minus mean square. So we need to find mean first. Mean, as we follow the table, so we have 17 over 4, and then we need to find sum x square. Sum x square, if we follow the table, we can get 81 over 4. After we finish, we just need to put them into the formula variance x. Variance x equals to 81 over 4 minus 17 over 4 square, and then we get 35 over 16. After we get a variance x, we just need to put them into the formula variance for W minus 2, and we can get 16 over 9 times 35 over 16, and we get 35 over 9. The conclusion is, this project demonstrates how probability theory applies to real-world situations, such as predicting the outcomes of a coin toss. It also highlights the importance of conducting experiments to understand how experimental results can vary from theoretical prediction, and how the repeat trials help to reduce the discrepancies. By extending these concepts, students can improve their analytical thinking and recognize the whole of the probability in decision-making process in everyday life. That's all from us. Thank you.